Hello everyone, hope you're doing and welcome back to my channel. Today we are discussing the solutions for the weekly contest 428 that happened on 15th of December 2024. And we have already discussed the solutions for example number question number 1, and here we are trying to discuss the solution for the question number 2. Okay, and if you want to give your suggestions like comments on what you felt regarding the difficulty level of this particular contest, you can do the same in the comment sections. And yeah, we can discuss the same like what you felt about the difficulty level. So currently we are discussing about the question number 2. Already question number 1 we have created a video and discussed the same. It was on the easier side. Question number 2 I will say is on the harder side, because if you see the acceptance rate here, it's around 50%. By the time I solved it, it was 50%, and after that it's slowly increasing. Like after the contest ended, the acceptance rate was around 50%. Okay, as simple as that. So let us quickly try to understand what is happening. This question was on the harder side. So yep, I will be showing you a solution which is 100% better than other solutions in terms of both space and time complexity. You can solve it and you will get to know the same. Okay, after you submit, you will get those statistics. Okay, you can check that out. So currently I will be using the algorithm which is Dikshita's algorithm. Okay, which is n log n time. I will be showing the solution with that approach. Okay, there are multiple ways to do it. Some claim that you can solve it using bfs, dfs and other stuffs, but I don't. Yes, if you maybe like because the test cases are like that, that those solutions also get accepted. But based on my gut feeling, I felt that yeah, this is not. See, bfs and dfs will come into picture when all the edges are having same weight. Okay, that is the question point number 1 that I want to tell you. I felt this is not the case here. Okay, so I felt Dikshita's algorithm is something that will be better, so I did in that way. Okay, and it's beating most of the almost every solution here. It's beating 100% both time and space complexity. So I'm going to show this solution. So let us quickly turn into the question. First of all, it's question 3387, maximum amount after 2 days of conversion. Okay, so if you see here, it's very difficult basically to explain the whole question to you in the first attempt, because yeah, they have not given it very logically. They have not given it. The questions are like the examples are, you can say, like these are open-ended examples. They're not conveying you many factors. Okay, these are not closed-ended examples. There are many things which are left for you to understand on your own. Okay, so yep, you will have to take a pen and paper and start tracing. Only then you will understand, because there are so many variables, so many names, and after all there are so many calculations which are not easy to track. Okay, so my request to you will be take a pen and paper, start tracking the examples. Only then you will understand what is happening here. Okay, so before that, let's see it. You are given a string initial currency. Okay, and you are starting with one. That is, see, you are starting, for example, you see here the initial currency is euro. Okay, euro is euro. Okay, so you are starting with a euro and you are starting with 1 euro. For example, you have $1. Similarly, you can say 1 euro. Okay, so you are starting with this currency with the unit one. Okay, as simple as that. That is your starting conditions. You are also given 4 arrays with currency pairs strings. See here, there are 4 other arrays. Okay, first array is this one, the pairs array. The other one is the rates array. And similarly the same for the number 2, the pair number 2 and the rate number 2. Okay, so what they're trying to tell you is that, see here, for example, if you talk about the pair, these are going to tell you, like for example, if you convert 1 euro to 1 USD. Okay, so the rate is going to be this one. Okay, this is going to be the rate for that. Okay, that's what they're trying to tell you. Similarly, if you convert 1 USD to one Japanese currency, JPY, okay, whatever it is, I am thinking it is somewhere related to Japan. So I'm saying the Japanese currency. If you convert a USD to Japanese currency, it will be around this particular rate. So what is this? See, try to understand this. If you have 1 euro and you are converting to one, that is, you have 1 euro and you're trying to convert that to one USD. So what will happen is it will be multiplied by two. That is, 1 euro is equal to $2. Okay, that is what is the value here. Remember that this is for day one. The one, see, these two are basically for day one. The two arrays that I'm highlighting on the screen are representing the day number one. Okay, in this question there are 2 days. Okay, this question is for 2 days basically. The first pairs, that is the pairs one and the rates one, is for the day number one, and similarly the pairs two and the rates two is for day number two. Okay, these are the rates on day number one, and similarly these are the rates on day number two. Okay, and these are representing this particular conversions. Okay, as simple as that. So again, let us come back to pair one first, because if you understand pair one, pair two will be on the simpler side. Okay, let's see, discuss pair one first. So if you convert 1 euro to US dollars, you are going to get 2 US dollars. If you convert 1 euro to in dollars, you are going to get $2. So 1 euro is equal to $2. Similarly, if you have $1 and you are trying to convert it to one Japanese currency, then you are going to get three Japanese currency out of $1. Okay, so these are the that is how it should be interpreted. Okay, and same is the case here also. This is for day two. Remember that this is for day two. So you should not confuse between day one and day two. Okay, that is very, very important, because otherwise the calculation will be totally wrong. Remember that. So let us quickly trace the example one first. So see, the idea here is you will have to see. you will do, it's basically the trading, right? After doing the trading, so this is the day one trading, this using these two pairs you have to do the day one trading. These are the day two tradings. After doing both the tradings, remember these are optional. You may not do any trade on day one, but you may choose to do on day two, or you may not do on day two also. Okay, so these are an optional. After the end of day two, basically you will have to return the max amount of money that you can have in the original currency itself. That is, the idea here is you started with a €1, then you can start doing this kind of tradings to convert it to other currencies based on these particular rates. And same you can do for day two also. These are optional, but yeah, you can do that. After that, you'll have to again come back to your original currency, and you have to tell how much money you have in your original currency, that is in terms of euro, how much euro you are going to have. Okay, so let us see the example one first. See, I'm not going into the detail of this question because like there are so much details here. You can go through it on your own. Okay, I'm just telling you the part that is most important. Okay, so I will discuss the example first, maybe then I will go back to the definition again. Okay, so yeah, see here, first of all, I am starting with a euro. Okay, so first of all, I'm converting euro to USD. Okay, that's what they're trying to do. On day one, they're converting euro to USD. Okay, so €1 will be converted to $2 US. Okay, as simple as that. So I have $2 now. Now in terms of same for day one, if you talk about this part, US dollars and the Japanese currency, so $1 will be two Japanese currency. Similarly, sorry, 3D Japanese currency. Okay, this is the rate. So currently I have $2. So in terms of Japanese currency, I will be having 2 into 3, which is 6 Japanese currencies. Okay, as simple as that. Now this is the end of day one. Okay, now I'm going to start the day two now. Okay, so what are the day two? See, I ended day one with the Japanese currency, so I have to start the day two also with the Japanese currency. Okay, I'm ending with day one in the Japanese, and day two will start with the Japanese currency. So now I'm going to again convert Japanese currency to US dollars, and the rate is 4 now. Okay, that is, each Japanese currency is worth $4. Okay, that is what they're trying to convey. Okay, so I will have to multiply this particular thing with 4, so I'll be getting $24. Okay, fine. In the same day, $1 is worth 5 5%. That is, yeah, 5 CHF. Okay, I'm not sure what is CHF, by the way, but yeah, it is some currency. Fine. So that is, each dollar is worth 5 CHF. Okay, so now I have $24. I will be multiplying them with a factor of 5. Okay, so I will be getting this particular value, CHF value. Now on the same day, 1 CHF is worth €6. Okay, €6. So currently I have this much US, CHFs. I will be multiplying them with 6 to get €720. So remember, one thing is very important. You will have to end in euros only. That is, if you see here now, at the end of the day two, if I come back to the original currency that I had, in terms of my original currency, I have 720 rupees now. Okay, 720 currency units now. Okay, so see the question here once more. See the part here that I want to tell you is, yeah, yeah, from here on. Also, the target currency can be converted back to the corresponding start currency at the rate of 1 by rate. So the time to tell you is, see, in the question number one, basically it's fortunate that we ended in the euro itself, but this will not be the case always. Okay, remember that part. Okay, so what they're trying to tell you is that, for example, see this, one Japanese dollar to US dollars is rate is 4. Okay, but the reverse is also true. That is, let us say you are having a US dollar and you want to convert to a Japanese dollar, then the rate will be 1 divided by 4. Okay, that is will be the conversion rate in that case. Okay, so that also is possible. That's what they're trying to tell you in this. Okay, and remember, one thing is very clear: whichever is the starting currency, initial currency, you'll have to return the answer in terms of that only. Okay, as simple as that. You can perform any number of conversions, including zero, using the rate one on date one, followed by any number of additional conversions, including zero, using rates two on day two. Okay, return the maximum amount of initial currency you can have after performing any number of conversions on both the days. Okay, in order. Okay, remember, day one should be first and only then the date. Okay, that's why I'm saying it should be in order first of all. Okay, note, the conversion rates are valid and there will be no contradictions in the rates of either day. The rates of the days are independent of each other. Remember, this point is very, very important, because let me tell you this, I'm damn sure that most of you will be doing the mistake here, that, see, this is not converted in example one directly. So if you are solving this question by example one, you are going to be in trouble. So see the example two also. In example two, what is happening is, see here, you're starting with a currency which is NGN. Okay, you're having 1 unit of this particular currency. Now if I convert NGN to euro, the rate is going to be 9. Okay, fine. If you talk about the day two, the same thing, same NGN, if I have to convert to euro, the rate is going to be 6. So try to understand what is happening. So one solution will be, I will not convert anything. Okay, I will remain as it is, so I will have one. But let's see the other possibilities. Let us say I convert. Okay, one NGN, say I'm starting with NGN, I have one NGN in the initially, in the day one I'm converting to a euro. So at the end of day one, I will having 9 euros. Okay, as simple as that. In the day two, I will have to convert them back to NGN. Remember that. Remember, whichever currency you're starting with, you have to end with the same currency only. Okay, otherwise it will not be a valid. See, the question, we have to return the answer in terms of the initial currency only. Okay, as simple as that. If you're not able to convert, if you're in a place where you're not converting, see, that will come example three basically. Then you cannot do that. That transaction will not be valid. Okay, as simple as that. If you're not able to convert back to your original currency. Okay, Fine. So I have currently 9 euros at the end of day one. Coming to day two, like this is the conversion rate, but yeah, I have to go to the reverse of that. Remember that the reverse is 1/6. That is, I have 1 euro that should be converted to 1/6 NGN. Okay, but currently I have 9 euros, so 9 will convert to 9 into 1/6. Okay, which is, you can do the calculation. It's coming as 1.5. Okay, so at the end of the second day, you are having 1.5 NGN. You started with 1 NGN. At the end of day two, you are having 1.5 NGN. Now coming example three. So here, if you see what is happening, see they are giving multiple currencies here, but the thing is, you cannot see. Let us say in the day one, you are having 1 USD. You are converting them to euro. Okay, so the rate is one itself. That is one. You had 1 USD that got converted to 1 euro. But remember, in the second day, they are converting it to a Japanese. But there is no link like how Japanese should be converted back to US dollars. So we do not have a link here. Okay, they can given the conversion from euro to Japanese, but from Japanese back to US dollars, how to do it, we do not know on day two. Remember, on day two, you cannot use the values given in day one. Okay, remember that part. These are the rates given in day one. These are the rates in day two. So these are not the same. Remember that they are totally different. Okay, if you are aware of stock market, every day the rates keep changing. You cannot use the previous day's rate in today. Okay, for today's calculation. So there is no way I can convert the Japanese dollars to USD. Okay, there is no conversion rate given. So that is the reason I cannot do the conversion. Okay, so this all of them I should not use anything. That is, I should not convert to anything from the day one to day two onwards itself. Okay, so there should be no conversion on day one and day two. I will have to return one itself. Okay, whatever I had initially, without I did not do any conversion, and I return the same. Okay, there's no need to make any conversions on either days. So yeah, and that was all for this particular question. Let us quickly see the solution now. So my solution is going to be very, very. See, I'm going to consider everything given to me. Okay. See. You can solve this using multiple approaches. It depends on the test cases. By the way, see if the test cases are, for example, if many people have seen, they prefer solving this using BFS and DFS. But I felt this is not the right way to do it, because see, BFS and DFS should be used when the first of all, like this question can be solved in graphs. Okay, do you agree with me in that? Because see, they're converging. That is, this kind of a graph is getting built. Okay, this has a link with this. Okay, and so on, a graph is getting built, and these are basically the weights. You can say the weights. Okay, in this case, the weight should not be added; it should be multiplied. That is something that you have to ensure. But yeah, these are going to be the weights. So this is equivalent to a graph question. First of all, next question comes like how should we, which graph algorithm we will use. So many people are using BFS and DFS, but I felt this is not the right approach, because see, BFS and DFS are important or useful when the all the edges are having equal weight. Okay, equal, or you can say same weight, and as similar as that, or they are not having any weight. They are, just you are converting a imagination to a graph problem to solve it, so you are all are having similar weight. But in this case, the weights are not going to be same. So that is the first reason why I felt this is not a right way to use the a traversal algorithm like BFS or DFS. So the algorithm that I will be using, see here, obviously none of the edges are going to have negative weight. Okay, and one more thing that is important here is, which they have mentioned here, is there will not be any cycles. Okay, there will not be any cycles. So these two things led me to believe that, yeah, the Dikshitra's algorithm will be the most better thing to do here. Okay, so let me show you my solution, what I'm doing. Before that, I'm just showing you one thing that I'm going to do. See, the idea here is, once you are in a day two node, okay, see, first of all, you are going to convert this question to a graph. Okay, that is fine. Now the idea here is, if you are in a node which is representing the day two, you should not come back to the values given for day one. Okay, so in short, to ensure that, what I'm doing is, I will be creating separate nodes for day one and day two. Okay, see here, let us say the currencies are A, B, and C. In my solution, these will be the nodes. Okay, for day one, the nodes will look like this. Okay, A. Okay, let me zoom in. So a comma 1, see, this is a tuple in Python. Okay, this is going to be the name of the node. Okay, a comma 1, which is going to represent the node A on day one. Similarly, this is going to be the node B on day one. This is going to be the node C on day one. Okay, so the nodes to which will be connected, see, first of all, each node here will be connected to only the nodes which are in the day one. That is all the day one nodes only. Okay, a particular day one node should be converted to other day one nodes only. It should not be connected to a day two node. Okay, as simple as that. These are going to represent the day one nodes, and similarly, these are going to represent the day two nodes. So we'll be starting at this particular point. Okay, which was the initial currency, that from there we'll be starting. Let us say here, I'm going to start from here, and I'm going to end it here. Okay, as simple as that. So see, this will be given like initial currency. So we are going to start the day one node of that particular graph. This will be the node for that particular starting point, and the same, that this node using this on the day two, that will be the ending point of that particular graph. Okay, as simple as that. This is going to be my solution. And like for the traversal purpose, what I will do is, each one node, that is B1, should be only related to B2. Remember, B1 should be connected to all the nodes present in, that is, yeah, according to the definitions given here, it should be connected to day one nodes only. Okay, B1 should be connected only to day one nodes based on the dependencies given here, but only node to which it should be connected The only data node to which it should be connected is the corresponding data node. Okay, for example, B1 should be connected to B2. Similarly, C1 should be connected to D2, C2, and so on. Okay, but only thing that is in my solution also, I have to ensure that if you are in a higher day, you should not go to a day which is below that. Okay, that is, if you are in a day 2 node, you cannot go back to day 1 node. Okay, that is something very, very important that you have to ensure. Okay, otherwise this whole solution will be a total uh, uh, thoughtless solution, because we'll have to debug a lot and it will be of no sense. So see, this basic should be very, very clear for you, so that it becomes very, very easy to apply the simple algorithm and to get the answer. Okay, so I've already explained. So these are going to be the day 1 nodes, these are going to be the day 2 nodes. Okay, all of them will be represent the same graph. Okay, and each corresponding node will see, for example, the day 1 node of the B currency B should be connected to day 2 node of the currency B. Okay, that is only connection that you can make. And once you are in a day 2 node, you cannot go back to any other day 1 node. Okay, that is again something. Okay, let's quickly begin the solution now. First of all, it's about how to get the graph. Okay, let us see here. So I'm declaring a graph. Okay, graph in the sense, like, see, it will store the node and the corresponding edges. Okay, how it's going to show the edges are again going to store in another graph. Okay, and ultimately the value is going to be the rate at which the conversion is happening. Okay, the weights are going to be the rate at which the conversions are happening. Okay, let's see that things are now. So I'm going to, first of all, I'm going to the pair 1, then I will go to the pair 2, and so on. Okay, in the pair 1, first of all, I'm just from what are the from and to values. Okay, that is, this particular edge is from the from node to the to node. Okay, so these are the two ones, from and to, are I'm just extracting from and to from the edges, that is from the this, for example, here the US dollar is going to be the from node, and the Japanese dollar is going to be the to node, and so on. Okay, and the rates are going to be the way they have mentioned it here. Okay, as simple as that. Fine. Then I'm extracting the rate from that. Okay, this is the rate, and then I'm going to mark those entries in my graph. Okay, so this is how the entries will be marked. If you see here, this is going to be my first entry. Okay, from node to node. Okay, then this is the rate of it. Okay, the rate is going to be the value in my this particular dictionary, as simple as that. Now the reverse, that is, I can go for reverse also, that is, from the to node I can go to from node. Okay, that is back to from node. Okay, as simple as that. For that, the rate will be 1 divided by rate. Okay, as simple as that. For that, the weight of the edge will be 1 divided by rate. Okay, this is how I'm storing it. Okay, this particular part I will come in a bit of time, just please hold on for this. But let's see the pair 2 now. So for pair 2, I'm doing the exactly same thing. Okay, it's the exactly same thing, remember that. So what I'm doing, I'm just extracting from and to values, I'm just extracting the rate, and then I'm declaring the edges. Okay, as simple as that. So this is the first edge, and this is the reverse edge for the same. Okay, this is the reverse edge for the same. The rate in this case will be 1 divided by rate. Now, fine. So I've mentioned these 2 points. Okay, now as you can see, the while declaring the edges, what I'm doing, based on, see, for the pairs 1. Okay, for the pairs 1 array, all the edges will be for day 1. For that reason, I am writing 1 here. If you see, I'm writing 1 here. All the values are having 1. Okay, as simple as that. All the values are having 1. And similarly, when I'm passing the pairs 2, basically, if you see here, this is the pairs 2. I'm giving 2 wherever possible. Okay, all are day 2 nodes, and their from and to both should be in the day 2 only. Okay, as simple as that. Now, the other part that I mentioned you is that this one. If you see here, every node in the day 1, that is, for example, B in the day 1 should be connected to B in the day 2. Okay, as similar as that. For that reason, I'm using this particular part. Okay, this is the part for that. Okay, the from and the to node in the, when I'm processing the day 1 nodes. Okay, I'm just making the connection. For example, the to node in the day 1 is going to be connected to to node in day 2 with a weight of 1. Okay, as simple as that. Similarly, the from node in the day 1 should be connected to the from node in day 2 using a rate of 1. Okay, as simple as that. So this is the part to ensure that. Okay, that is, both of them are should be connected. Okay, that's what I'm trying to ensure. Okay, these nodes should be connected to the corresponding nodes in the day 2. Okay, for that reason, I'm using this particular code. Okay, I hope you are getting the point now. uh, yeah, that is all for it. Okay, now I'm going to start the Dixitra's algorithm. Okay, before that, so I hope you're aware of what is the Dixitra's algorithm. So here the idea here is, we will visiting, see here, see, we do not have to find the shortest path, we have to find the longest path, that is the part with the maximum weight. Remember that, that is should be the objective, not the other way around. Okay, so we'll modifying the algorithm and applying it based on our need. Okay, so this particular thing, I'm using it to store the current, like how much currency I'm having when I visit a particular node, what is the amount of currency that I'm having at that particular point. Okay, as simple as that. And this is going to be the answer. Okay, fine. Okay, you can remove this answer. Basically, like, yeah, I changed this solution. That time I use it. I have currently it is not needed. Fine. So next, what I'm going to do, I'm using the heap now. Okay, so this is going to be the first element of my heap. One thing that you might be knowing from my videos is that whenever, see, in this case we need a max heap. Okay, we need a max heap. But by default, whenever you are using a heap from this particular library, it will behave as a mini heap. Okay, to make this mini heap, work as a max heap, what I'm going to do, all the values that I'm going to insert here will be having a minus sign. Okay, as simple as that. So this is going to be telling me what is the currency that I'm having currently, okay, and this is going to be the details of the node, okay. So this is going to be the node name. So this basically this whole thing is basically the name of the node, okay. This is the currency and this is the day of the node, okay. So like this, like something like this, okay. This whole thing is going to be the name of the node, okay. So this whole part basically is going to be the name of the node, okay, and this will tell me the value of the node, okay. This is going to be the starting value. So the initial currency is going to be the starting node. It has a value of 1, so I'm just starting a minus 1 additionally, okay, simple as that. While then this loop will continue till the heap has any element, okay. Then I'm doing a heap pop. What I'm popping, getting the value and I'm getting the node name, okay. The node name has the currency and the day, okay. I am multiplying the value with a -1 because while pushing also I multiplied with -1. So I'm doing that. Then I'm just checking whether the amount, that is, if you see here, I maintained an amount array also, okay, which has a default of int, okay, as simple as that. So it's by default, it will have 0 values for all the nodes, okay. So then I'm just checking whether the node, okay, that is the amount that I'm having in this particular variable is already greater than the current value. If that is the case, I should not proceed further, okay. This will be a stopping condition then, okay, as simple as that. If that is not true, see, most of the cases it will not be true. What will happen then I will have to mark that first, okay. In the amount that is for this particular node, this is the value with which I am having inserting, like starting the process, okay, simple as that. This you have to print. Next, I will be visiting all the neighboring nodes, all the adjacent nodes, and I will be based on the rate of the transfer, I will be multiplying that also, okay. So what I'm doing for node comma rate in graph, okay. So this is the graph. I'm just going through graph.items for this particular node, okay. This is the node basically. For this node, I'm visiting all the corresponding neighbors and their rates, okay. This is the rate and this is the node, okay. For each node, what are the values? Next currency and the next day, okay. So each, that is the node name, has these two things, okay, currency name and the day, okay, fine. The idea here is, see here very currently clearly, for the current node I am at this particular day, okay. For the neighboring node I am going to be at this particular day, okay. This is the day for the neighboring node. So the idea here is, next day should not be less than equal to current day. That is, when I'm going from the current node to the neighboring node, I should not go from a day 2 node to a day 1 node. For that reason, I've included this condition, as simple as that, okay. If that is not the true, what will happen next? Then I'm going to calculate the next value, okay. Value into rate is, see, value from where it is coming, value is going to be the current node's value, okay. This is the one. And from where the rate is coming from this, okay, as simple as that. Rate is kind of a weight of the edge, okay. Yeah, I'm calculating the next value and then I'm just checking whether next value is greater than the amount of this particular node, okay, amount of the adjacent node. If next one is greater, then I'm just pushing it into the heap, okay. I'm just doing heap push. This is the name of the heap and this is going to be the value that I'm going to push. What it is, I'm just multiplying the next value with the -1 and then I'm passing the node name. What is the node name? Node name is a combination of the currency name and the day name, okay, like this. It will be like this. Fine. This will keep continuing, okay. This will keep continuing. Okay, let me zoom out. This particular while loop will keep continuing, okay. At the end, basically, remember one thing here. The idea here is, see, always the minimum possible answer in this case is going to be 1, okay. Why? We are starting itself with 1, right? The answer is going to be 1. The minimum answer is going to be 1. Where value, any value less than 1 is not acceptable here, okay. That is the reason why at the end, if you see what I'm returning, okay, maximum value of the maximum value of either 1 or the amount that is in the amount array. I am passing the initial currency comma 2. What is 2? 2 represents the day, okay. For example, let's say the currency is A, so the value at this particular node, okay, the day 2 node of the same currency is going to be my answer, okay. The day 2 node for the initial currency is going to be the answer in the amount dictionary, okay. This is the one, okay. This is the node name, and for this node, what is the value in the amount dictionary? That is going to be the answer. If that is less than or equal to 1, I am going to return 1, okay, as simple as that, okay. That is going to be the solution. One thing that people may ask is like, why you are not including if condition? That is, whenever we are visiting this particular node, I should return the answer. Why I'm not doing? See, the result is very clear. It may have values less than 1 also, okay, less than 1 also. For that reason, we should only return the minimum value of 1. Anything less than that will not be returned, okay, as simple as that. So this is the solution that I am preparing. So see, I will again repeat. I'm creating a graph. In this graph, I'm just including the nodes. For each edge, there has to be reverse edge with the reverse rate, okay. And then, as I mentioned, I'm creating a structure like this. So each node in the day 1 should be linked to a corresponding node in the day 2. So for that reason, I have included this part in my code. Yeah, this is the part. And other than that, I'm starting the Dikshitas algorithm. So this is exactly same as what I've done. Okay, I'm using a min heap. That is, I'm using a max heap, but using a min heap. That's the reason I'm including minus values. And yeah, we have to pop out, make it positive, and then you have to check whether the current, that is, if this node is already visited, and if you are already having maximum value in that case, I should not visit continue further. If that is not the case, update the value in the amount dictionary. This is the amount dictionary. This is where I'm using in the returning value also. And then for each of the neighboring nodes, what you have to do, just get the node, calculate the next value, and then if the next value is greater than the amount that is marked here, remember this is a default dictionary. That is, by default the value shall be 0. So anything is greater than 0, that is if you're wishing for the first time, the value will be 0. If the value is greater than 0, that is here, then you have to push that particular element to the heap. Okay, this is going to be the element, and this will keep continuing, and ultimately you'll have to return based on the initial currency, like by what value you are going to reach the initial currency on day 2, that will have to return. Okay, as simple as that. So yeah, and that was all for this. Like, so you may ask, right? Let us say I'm because as you mentioned, like it's optional. I need not do any trading on day 1 and day 2. So how to simulate that? So the idea here is, in that case, you have to return 1, right? That will be the answer, right? So for that reason, I'm marking this also as the reason. This is the answer. Okay, as simple as that. And remember one more point. Like, see, let us say we are, for example, in the example number 3, we never reach the initial currency after the day 3. If you follow like these things, okay, if I follow like the way, for example, there's no connection between this Japanese currency and the initial currency with which it started. Okay, in that case, what will happen is we will never reach the initial currency node in day 2. Okay, we will never reach the initial currency node in day 2. Okay, this will never be reached. So the default value here will be 0, will be marked here. Okay, so this will be marked as 0. Okay, because remember, this is a default dictionary, right? This is a default dictionary, so the default value will be marked here. For that reason, I'm taking either return this or the max, which is 1. Okay, as simple as that. So yeah, but that will be covered through this case. Okay, so if you are anyway you are like planning to skip both the training sessions, day 1 and day 2, in that case, the connection will be handled through this. Okay, I'm passing the maximum value as 1. So yeah, and that was all for this video. This was the solution for this. Okay, this was my tactic to solve. Like, see, many people will have this, see, they will clear that we have to use graph, but how to use the graph? Because see, the graphs are not connected as such, because the day 2 values, that is I just marked for day 2, should not be used on day 1, as simple as that. Okay, as simple as that. And once you are in day 2, should not use the adjustment meant for day 1, and on day 1 you should not use the adjustment for day 2. Okay, and once you are in day 2 notes, you cannot go back to day 1 notes. Okay, these are some other restrictions. For that reason, I've decided to keep them separate, and this is how I'm doing it. So yeah, and that was all for this video. I felt this slightly on the harder side, because, like, yeah, just try to solve it on your own. I'm damn sure that you will be making a mistake here because of this. Because of this reason, many people are making mistake here. You can check out multiple values, but yeah, this solution is 100%. It's 100% better in terms of time and space complexity. And I'm giving you the solution. This will be there in the comment section. Just go and check it out. I already know this video is slightly longer, but yeah, I have tried to give you the best that you can get. Okay. Remember, if you're using like many people are doing, if you're using BFS or DFS in an intro, you will be stuck, because you will not have explanation of why you are choosing BFS DFS. Okay, that will tell them the wrong idea, that you are just recalling the solution and you are writing it. Okay, you should be having a reason, basically, why you are using a particular approach, or why you are using a particular data structure. Okay, I have the reasons. I felt like this is the exact scenario where the discrete solver will be useful. Okay, the graphs are having now, they are not having cycles, they are not having negative edges, and for this reason, and at the same time, all the edges are not the same. Okay, but all the three conditions are very much supportive to Dikshitras algorithm, and I'm using this for that reason. Okay, so yeah, and that was all for this particular video. If you like my efforts, please subscribe to the channel. This really gives a lot of motivation to continue further. We have already submitted already posted the solution, for example, that is question 1 and question 2, and we'll be posting the solution for question 3 soon. Okay, so yeah, and that was all for this video. See you tomorrow. Thanks a lot.